It is now after the AP exam, and we're going to do a short unit on matrices. You will find matrices useful for if you keep on going on in calculus, and even if you do some other things in math, matrices are used quite often. It's no longer part of our curriculum because of time issues and things that is expected to be in the curriculum according to the state framework and all that. So anyway, but it's important for you guys to have this understanding for possible future things. So anyway, a matrix is an arrangement of data. It's listed in rows. The rows are horizontal, and columns. And so, for example, in this particular example that I have right here, it's a 3 by 5 matrix because it has 3 rows, 3 horizontal rows, and 1, 2, 3, 4, 5 columns. Okay, and when you list it, you will always list it rows by columns. Okay, and if they want an individual term, so if they wanted the 2, 3 term, that's the second row, third column, so that would be 8 in this particular case. And M 3, 1, third row, first column, so that would be 11. We can do operations on matrices, and we will be doing several operations on matrices. Now for today, we're only doing scalar multiplication and addition or subtraction. Now, scalar multiplication is a lot like distribution. That's really basically what it is. When you're doing scalar multiplication, you do not change the dimensions at all. So the fact that we had a 2 by 2 matrix, we're still going to have a 2 by 2 matrix. But essentially, we're just distributing, so negative 3 times 5, negative 15, negative 3 times negative 2 is positive 6, negative 3 times negative 4 is 12, and negative 3 times 0 is 0. Okay, addition and subtraction. Really, I mean, subtraction is just adding the opposite. But to be able to add or subtract matrices, the matrices must have the same dimensions, the exact same dimensions to add or subtract. If they do not have the exact same dimensions, then you cannot add or subtract those matrices. So we've got a bank of matrices here, and so A, B, and C, and so problem number 2, this example, we're doing A minus B. Now, they're both 2 by 3 matrices, and so I'm going to have a 2 by 3 resultant matrix, okay? So 5 minus a negative 4. And yes, I realize probably you guys can just do that in your head, but it's notes, so we're going to go ahead and write it out a little bit more. Negative 3 minus 3, 1 minus a negative 9, 2 minus a negative 2, 4 minus 0, and negative 6 minus 5. And so our resultant would be 9, negative 6, 10, 4, 4, negative 11. Okay, now some of them, you know, it's like you probably can just do them in your head. Now, don't try to do too much all in your head. So for example, on this one, we can actually mix scalar multiplication with addition or subtraction. So 3c plus 2b, okay, again, c and b are both 2 by 3 matrices, okay, and this would be the least amount of work I should see. I do not want to see just a final answer on something like this. I want to see at least one step before the final answer. So 3c, so 3c, so I'm doing scalar multiplication of 3 times that one, so I've got 9, and then 2b. Okay, so plus 2 times negative 4, so minus 8. Okay. 3. Sometimes it's helpful to go ahead and do kind of answer blanks almost. Then you can maybe just kind of go through and do all the 3 times c. So 3 times 5, 3 times negative 2, 3 times 7, 3 times negative 3, 3 times 1. And then we're adding, okay, 2 times b. So 2 times 3, 2 times negative 9, which is really negative 18, 2 times negative 2, 2 times 0, 2 times 5. Okay, which our resultant then is 1, 21, negative 24, 17, negative 9, and 13. Okay, last one here, find, solve, for matrix M such that 2a minus 3m equals c. Okay, now the a and the c are referring to the matrices up here. So let's, now we could actually do our algebra here first. We could do something like 2a minus c equals 3m. So m is 1/3 times 2a minus c. Okay. And so now we know what m is going to be equal to, and now we need to solve for it. Again, don't do too much all at once. Now we know a and c are both 2 by 3 matrices. So just getting it set up here. So 2a, okay, so 2a, so I've got 2 times 5 and 2 times negative 3. And I've got 2 times 1 and 2 times 2. And I've got 2 times 4 and 2 times negative 6. Okay, minus c. Okay, so minus c, so minus 3, minus 5. Minus a negative 2 and minus 7. And finally, minus a negative 3 and minus 1. And so we can see that we're going to have 1/3 of 7. No decimal approximations. 1/3 of negative 11. 1/3 of 4. 1/3 of negative 3. 1/3 of 11. And 1/3 of negative 13.